text by removing all the stop words. Now you're left with words that are not commonly seen.
So if you have an email that says that the will is in the can, you'll lose the entire context.
Sometimes, yeah, you'll be left with very little, yeah. Yeah. So, we're also there's a couple of other modules that we're importing, random OS, the glob one, so we can actually get the emails, and the regex module. Okay, so again, I'm going to be explaining what this is, the WordNet lemmatizr, but we're just going to instantiate that and store it in a variable. And we're also going to get all the stop words. So the way you would do that is call stopwords.words, and we want English. You can actually specify languages. I'm not 100% sure on what all the languages that they cover, but for all the examples right now, we're just covering English. But there are several other languages, and in fact, the functions might work kind of differently for.
There are 14 different languages.
14 different languages. And we're going to create two lists. So one of them is going to store all the ham text, and one of them is going to store all the spam texts. So each item in this list should be a separate email. Okay, so we're just going to go down here, and we're just going to loop through the directory, kind of globbing all these files and putting them into the lists. So by the end of this, once we loop through both paths, the spam folder and the ham folder, both of those lists defined, ham text and spam text, are going to contain one email per item.
You know, an interesting thing to propose is to assess the IQ of the author based on the content of the email.
That might be something interesting, yeah. I mean, yeah, so for each one, now we're going to go through each list. So remember, each item in this list contains an actual email, and we're going to label it. So we already know that the spam text list contains spam. So looping through that one, we're going to create a tuple that has the actual email's content next to the label for it. So each tuple contains the content, the label. And so for ham text, we're going to go through, do the same process. We already know ham text list contains all ham. Good emails. Sorry if I didn't explain that. Ham is good email, not spam. The opposite of spam. And we're going to label it as ham. Okay, so the next thing we have to do with this is shuffle these emails, kind of randomize it. Because most likely if you're going through this, if there's some kind of naming convention that these texts are using, it's going to be in a certain order. We don't want that. We're just going to shuffle it up real good so we get a nice sampling. And the next step we're going to do is actually create the feature extractor. And this is probably the main part of a classification system, is the feature extractor. Essentially, a feature extractor takes whatever takes the label and the content of whatever you're giving it and gives it some kind of a feature. And this is where the creativity kind of kicks in. You basically get to decide, you know, how are you going to categorize this document based on what features. And so for this one, I actually decided to use the existence of words. So what I'm going to use as my feature are, you know, I'm going to look at each document, see what words exist, and then later, it'll actually categorize things based on what words it finds in the document you just gave it. Okay, so what we're doing here is we're actually finding we're using the lemmatizr that we created earlier, and we're actually going to make everything lowercase. All the words are going to be lowercase, and this is just to normalize it. We don't want it to differentiate between different words based on certain letters being capitalized and such, so we're just going to normalize it. And then we're going to go through, and we're going to loop through each one. So if the word is not a stop word, if you remember earlier that we took all the stop words and put them into a list called common words. If it doesn't find that word in there, then we'll consider it a feature, or you know, it's a key trait. It's a word that's worth looking at, and we'll store it in the features array. And then we're just going to return that array of features. So every document you give this this function, it'll return all the features that are found. Basically, the existence of all the words in there. So it'll have word and then equals true. And there's actually a reason that it's formatted this way. I believe that's the next slide. At the bottom here, we're going to run through each email, run it through that feature extractor. So in the end, now that we shuffle them all together, we're just going to have a bunch of features for any given piece of text. Is there any clarification needed on that? Just, questions? Yes?
Why did you say right?
Right. I program in several different languages, and every once in a while, it's hard to keep track. In fact, when I started doing this, I typed in use some module. I think I did use NLTK, and I was like, oh my god, you know. So
Shankar, welcome to Are You Smarter Than a Fifth
thank you. Yeah, I mean it gets confusing, but yeah, sorry. Catch me next time I do that. I'll give you 10 cents every time. There we go. Okay, so basically, one of the things about this classifier specifically is that all the features must be binary, so, you know, true or false. So it has to be things like, you know, the existence of certain words or part of speech tags. If you get into things where the features that you're selecting happen to be outputted in decimal form or something, it doesn't really work. So it has to be binary. Using the same example for the feature selector earlier, instead of doing the existence of words as grab those as features, we could do just what types of parts of speech it contains, or whatever other features that you would like to do. And you can actually take features that are non-binary. So if, let's see a good example. Okay, let's say you took the syllable count divided by the number of words in any given text, and for whatever reason you're considering that to be a feature of a certain category that you're assigning things. You can convert it to a binary feature in a process called binning. It's basically just what you can do is at the bottom here, you'll see instead of doing earlier we did the word itself and true if it existed, you would actually do 11. So let's say the number that you came out with was like 10 point something, you know, some random number between 11 and 13. You could actually do it as a string. 11 is less than x is less than 13. And you'll see why this works later, because as far as NLTK knows, all it's seeing is that string and comparing it with other strings that are exactly the same to see if they match. Alright, so now that we have all the feature sets, so we ran all these emails through, we shuffled them up, we ran them through this feature selector. What we're actually going to do now is get a sampling of it. We're not going to use all of it. We're just going to sample a portion of it. So what we do is here we get the length of the feature set, and we multiply it by some fraction to get just a portion of it. So here I'm getting 70% of it. And then at the bottom there, I'm going to at the bottom of it, I'm just going to grab one portion of it and have that as the training set and the other portion as the test set. And what that is the training set is essentially what our classifier is going to use to learn with. So it's going to look through all these feature sets. So it'll get each set of features, and then whether it's spam or ham. And as it goes through each one, it kind of starts building these probabilities for the likelihood of finding any one of these features in any given document. The test set is what we're going to use later to actually test out our classifier on, to actually get a kind of an index of how well it's doing. So they're two completely different samples from the same data set. And you use one to train it, and then you test it on the other half. And at the bottom, we're actually going to run this function using our naive Bayes classifier. The function is train. It's fairly straightforward. And we would give it our training set. Okay, so I don't know if you caught that. So we trained it, and then we outputted it to, we stored that in a variable called classifier. And you can later go through, once it's done, this actually is a lengthy process. So that last part where you saw assigning that to a variable, actually going through and training it, is a very lengthy process. It takes a significant amount of time, which is what earlier I mentioned is the coffee's for. And we can now later go, and once it's done, you can actually have it print the labels that we assigned each thing. So if we had multiple labels, let's say we're creating a document classification system that says any incoming text, we're trying to assign it, it's scholarly articles, let's say. So we have categories of mathematics, biology, computer science, a bunch of labels. It'll output all the labels that we decide to use. For this one, we only defined 2 labels. We had ham and spam. And at the bottom there, you can actually, on our classifier object, you can actually run the accuracy function, and you would essentially give it the classifier and the test set, and it would output how accurate it is based on what it found using the test set. This final function here is show most informative features, and this is something really interesting. I think I spent a couple hours just running my classifier over and over again on different documents to see what it would do, because sometimes it's really funny. But you'll see actually this right here, these features that it outputs are very specific to the time period, and they're very specific to Enron. I only outputted 20 here, but if you output a lot more, you'll see words like energy commonly pop up as ham and certain other words. Also another note is CC is now a feature for ham. And you'll see as time goes on, actually, spammers will actually start noticing that and change their techniques, so they'll start including spams with the word CC in it. And so it's a constant back and forth as spam detectors get better and spammers get better. And you may even want, as your feature selector, you may even want to remove all words that are less than a certain length. Maybe you don't want to consider those features. You'll also notice names are actually appearing in ham. I didn't actually go through this earlier, but you would have to find a data set of common names. That's not a likable quality to really have. In fact, you might get a better accuracy if you remove common names also from the emails. So keep it strictly just keywords. And on the right side, you'll see the spam. Common words, that you would expect to see in spam emails. Prescription, doctor, super. There was actually a lot more profane, but I trimmed it down well enough. So.
2004 appears in spam and 2001 appears in ham.
Yeah.
Can you explain that?
Can I explain that? I mean, it must have been like the spam email must have been about something like futuristic or trying to market you something that's years ahead of the time,
Yeah, so
Emails were collected
Yeah,
before
collected
2004.
too. It's just one email.
Right. So that they're trying to market you something that's ahead of its time or something. Like, oh, this is the future. I have no idea.
They try to put it at the top of your inbox. The dates on the spam.
That may be it. Yeah, that may be true. Yeah.
Is the ratio?
Yes. Thanks for bringing that up because I would have completely missed that. What you're seeing on the very right column is actually the ratio. So you'll see before the colon, there's a certain number, and then it's 1. So basically, okay, if we look at the first, if we look at in the spam column, if we look at the first one, 2004, the label is spam, and the last column, it has a 43.5 to 1 ratio of that being a spam feature versus a ham feature, and that's what that is. It's pretty interesting to see, if you change the size of your data set and certain other features, or you can actually, you'll see how those numbers really fluctuate a lot. Okay, so this is the final one. This is just a simple loop that I created to kind of, so that it's usable once